an archaeobotanist, and I study woody plants from archaeological sites. I am one of many people in this less-known field who are trained to skillfully and meticulously dig up dead people's trash from the past and analyze it. It's not as creepy as it sounds, I promise you. But I was drawn to this field because I am curious about nature. I'm curious about how one aspect of nature is related to another, as well as how this relationship affects the essence of being human. In my role as an archaeobotanist, I study the complex interaction between plants, climate, and people in the past. And what I've come to realize is that our curiosity with plants began a long time ago. It began in many ways, began in many different parts of the world, and has mostly accumulated with time. We need them. We want them. We turn to them for all sorts of energy solutions. We plant them and we destroy them. And we do that at times because we need to, but sometimes we just want to. The truth is, we have quite an interesting story with plants, and it goes way back in time. It goes back to roughly 2.5 million years ago, when our ancestors started behaving in ways that are different from that of our primate relatives. And through this cultural evolution, we have thrived on the ability to store, accumulate, and transmit cultural knowledge. This ability gives us a competitive advantage when competing for resources against other living organisms. And plant knowledge has accelerated this advantage greatly. And one of the things that I like about studying plants is uncovering many different ways in which we have used them. Take trees from Southern Africa, for example. In the year 2016, an archaeobotanist by the name of Dr. Sandra Lennox discovered the remains of the camphor bush tree at Sibudu Cave, which is located in South Africa. The remains of this tree were dated to approximately 58,000 years ago to the Middle Stone Age. And Dr. Sandra Lennox was the first one to suggest that this tree in particular was collected by the people who lived at that time and used specifically for its medicinal properties. It's a plant we are all familiar with today. The leaves of the camphor bush tree are chewed or smoked or taken in as a snuff because they can treat many ailments, basically. It also has strong narcotic properties that can cure your stress, anxiety, stage fright, whatever you have. Something that would be great before any TEDx talk. And I wish I did that today. Overall, it's a great source of relief for many things. When the remains of this plant were discovered at Sibudu, it wasn't quite clear just how some of its useful properties were extracted from it. But fast forward to the year 2020, when I was conducting my own research, I had the privilege of analyzing wood charcoal from Bongekile Cave, which is situated not too far from Sibudu. And while analyzing the charcoal from Bongekile Cave, I also discovered the camphor bush tree. But the remains of this tree at Bongekile Cave were dated a little bit further back in time to 74,000 years ago. What was interesting about the camphor bush tree at Bongekile Cave is that the wood remains of this plant had clear evidence of having been burnt when the plant was not completely dry. And what I discovered to support this notion is the presence of wood radar cracking, the kind of cracking that happens when freshly harvested wood is burnt. And this is what I believe was done to the freshly harvested camphor bush tree at Bongekile Cave. It confirms that people first took advantage of the medicinal properties of this plant tens of thousands of years back in the late Pleistocene. And not only that, they knew how to extract these properties using fire. Now, the practice of burning medicinal plants or plants with toxic properties is not an odd case at Bongekile Cave. There have been other instances where plants that we know today to have medicinal properties or toxic ones were burnt in the past. For example, the tamboti tree, or Spirostachys africana, was also discovered in parts at Sibudu Cave. But these discoveries and many others that I've come to be aware of have actually gotten me to think a little bit more about this. Is there something that Stone Age people knew about all of these plants that we are not aware of today? And the answer to that question is easily yes. there is a lot we are not aware of about the uses of many different plants that we have, particularly in Southern Africa, because we have thousands of different species and we depend on a few of them. In other words, there is a lot more we do not know about the uses of many different plants in this subcontinent that have sustained humanity for hundreds of thousands of years. The potential to recover this lost knowledge, so to say, is only increased occasionally when we find remains of these plants in places where people used to live in the past. And related to this, and my personal favorite part about studying plants, is uncovering the many different ways in which we have adapted to our environment through plants. Plants have a long evolutionary history that is a direct climate record of our planet. And this is by far the best gift that they give us today, apart from toilet paper, of course. My point is, we share an environment with them. And yes, they provide oxygen, that's beautiful. But the fact that they've been around way longer than we have means that they know our environment much better than we do. Millions of years of evolving against a wide range of environmental conditions have dictated how trees diversified into different species. And that's the reason why each and every tree living today is adapted to a unique set of environmental conditions that allow it to thrive. The same adaptation is reflected in the wood microstructure of all of these woody plants. Trees are made up of millions of microscopic cells that we get to study in my field and answer a wide range of questions. The arrangement of wood cells is unique for each and every plant, like a unique, distinct fingerprint that you can use to identify any species from a tiny little bit of it and reconstruct the whole plant, basically. And this is the same method that I used to investigate a possible climatic impact of the volcano super eruption that occurred 74,000 years ago. What I did is I used the woody plants from Border Cave to reconstruct the plants that grew at that time, as well as the conditions of their growth. And after analyzing thousands of little bits and pieces of burnt wood, I was able to actually infer the climate that prevailed in Southern Africa using tree remains. And the importance of this event, if I may explain a little bit, is that it didn't just occur 74,000 years ago. It has been suspected to have caused a near extinction of our ancestors who lived at the time. And the popular assumption around this event is that it unleashed global climate stress that affected the resources on which people depended to the point of reducing the numbers of Homo sapiens who lived at that time. But after reconstructing some more than 50 different tree species that grew in Southeast Africa, I was able to actually infer the climate that prevailed in this part of the region. Real yellowwood, the African species of all life, were some of the trees that grew at that time, and one of many species that require plenty of moisture as well as very warm conditions in order to grow. Sneezewood, as well as the common wild pear, were also one of the plants that I discovered that grew in Southeast Africa. And through these plants, I could reconstruct that the climate was favorable enough for these and many other plants indeed to grow and mature enough for people to use them as firewood. But what's important about all of these trees is that they seem to suggest that the climate was not only favorable enough in Southern Africa, but this impact, the climatic impact of the volcano eruption in question, was not that significant in this part of the world. And what's important to note is that these trees, the tree resilience that was demonstrated by these trees, proved to be useful not only just for the plant life, but for all the people who depended on all the plant resources at that time. Now, our history is full of many similar events that are just waiting to be dug up in the past and learned and understood for our own sake. If you ask me, trees are still going to play a very important role in defeating life-threatening situations and surviving to sustain other living organisms. They've done it many times over in the past. Trees appeared approximately 380 million years ago and have survived all major extinction events since then. Who's to say that they won't be the heroes of the current one, as well as many others in the future? Thank you.